All right, so these are the notes for college algebra. We're going to be working with set builder, interval notation, number line graphs, absolute value, and distance. So our notes start by saying in set builder notation, the elements of the set are described but not listed. So an example here is, and we read it as this right here. It says the set of all x such that, so this line is such that. So the set of all x such that x is a counting number less than 6, okay? So that's your set builder notation. Now, the same set can be written using the roster method. That's what we kind of talked about yesterday, where you have a set and inside it you have elements. So when I read this, it says counting numbers, we know those start at 1, so 1, 2, 3, 4, 5, 6 to infinity, but it says they have to be less than 6. And since it says less than and not equal to, we stop at the number before 6, which is 5. So the roster method gives you braces because you're going to have a set and a list of numbers, so 1, 2, 3, 4, 5, because those numbers are the natural numbers that are less than 6. Okay, now we get into interval notation, and this is something you may have seen from Algebra 2. So here it says some sets of real numbers can be represented using interval notation. Suppose that A and B are two real numbers such that A is less than B. So what this pretty much means here is when you write your intervals, depending on, you're going to see in a moment, parentheses or brackets, the smaller number or the least number is always going to be A, and that's going to be on the left side when you write your answer, and B will always be the greatest number. So this is going to be smallest or least to greatest. All right. Now let's talk about the several types of interval notations you will see. So here we go. It says, first off, we have the open interval. An open interval is going to mean that you're going to have open circles. It doesn't necessarily have to be both of them, but more than likely it could be. Okay. So here I'm going to read the definition, and then we're going to talk about the graph. So the open interval A comma B represents the set of real numbers between but not including A and B. So if we're thinking about interval notation, okay, so not included means parentheses. That's why you see a parentheses for A and a parentheses for B, because they're not going to be included. When we talk about our set builder, x such that x is less than x, which is less than B, because A is not included and B is not included, therefore there should be no equal bar here because they're not included. And then it says x is greater than A is less than x, and x is less than B, x is less than B, okay? Now here, let's talk about this graphical representation. Now, we have parentheses right here, and this is gonna represent A, and this is gonna represent B. So smallest to largest. Now notice we have parentheses here, and we talked about that being not included. So graphically, something else you might see is an open circle. So an open circle and an open circle, which means that they're not included. That's why we use parentheses, just so you see that they are the same thing. So not included, not included. Smallest number is A, largest number is B. Open circles, parentheses, because they're not included. Now this definition will say the parentheses in the graph and in interval notation indicate that A and B, so the endpoints A and B, are excluded, not included, from the interval. Okay. And this is the way you would write it. It's a segment, so A to B, least to greatest, not included, parentheses. All right, let's take a look at the closed interval. So closed interval is going to mean that it is closed, and that's going to be closed circles on those endpoints. So the way we represent this is brackets, okay? So know the difference. Parentheses represent not included. Closed circles, brackets, represent included. So bracket A, comma, B, bracket, represents the set of real numbers between and including A and B. Okay, so here bracket A, comma, bracket B. So once again, we talked about this, brackets are closed circles included. So here it makes sense when we write our set builder notation that x such that A is less than or equal to. It's equal to because that's a closed circle bracket. X, which is less than or equal to B. And here it goes on to tell you x is greater than or equal to A, and x is less than or equal to B. Now when we take a look at the graphical representation, you see these brackets, and we talked about that being representative as a closed circle. So brackets mean closed circles. Again, our least value is A, and our greatest value is B. So A should come first because it's smallest, B should come second because it's largest. And brackets are there because they're both closed circles at the endpoints. So it goes on to say the square brackets in the graph and in interval notation indicate that A and B, the endpoints, are included in the interval. All right, next we go on to the infinite interval, and we have two infinite intervals. The first one we're going to talk about, it says parentheses A, comma, infinity, parentheses, represents the set of real numbers that are greater than a. So here we can look at this graph and we can see it goes from a, whatever the value of a is, and it heads towards positive infinity. So here, parentheses a comma infinity, parentheses equals x such that x is greater than a. Okay, so these two are equivalent statements. The infinity symbol does not represent a real number. That's important. And because it does not represent a real number, we don't know the value. Infinity will always have a parentheses, always. Whether it's positive or negative, it will always have a parentheses because we do not know that value, okay? From here it says, it indicates that the interval extends indefinitely to the right, okay? So what does that mean? Well, take a look at the graph. This statement indicates that it goes to the right to infinity forever, okay? Now, graphically, once again, the graph is pretty straightforward, but this is a parentheses, and you have to start making that connection that it's an open circle. And the arrowhead goes towards infinity. Again, this representative of A, and this heads towards positive infinity. And it says the parentheses indicate that A is excluded from the interval. And the parentheses around infinity just means we don't know the value, so we can't just put a bracket because it's not really there. We don't know the value. All right, let's take a look at the other one. So that first interval went to infinity. Now we're going to take the next interval where we start at negative infinity and we approach some number and stuff. So the infinite interval parentheses negative infinity comma b bracket represents the set of real numbers that are less than or equal to b. Now you might be wondering, why is it equal to it? Well, because if you look at the end, it's a bracket, right? Brackets are closed circles, they're included. So equivalency, parentheses negative infinity comma b bracket equals x such that x is less than or equal to b. So here it says the negative infinity symbol indicates that the interval extends indefinitely to the left. Okay, so once again here, hopefully you're starting to recall this and put the information together. That's a bracket, so we understand that this is a closed circle. Okay, and it says the square bracket indicates that b is included in the interval. So again, this is my furthest left, that heads towards negative infinity, and my furthest right, my larger value, is b at the end right here. Okay, and then in the book on page 2, or table P2 on page 11, there's 9 possible intervals. If you want to take a look at the textbook, you may do so. Let's go ahead and go on to example 3, expressing each interval in set builder notation and then making a graph of it. So for letter A, first off, I want you to notice that we do have parentheses, okay? So parentheses on both sides. Now we're going to start with our notation. So it's kind of right here too. So I'm going to start with braces. X such that. Now notice this is from one endpoint to another endpoint, and they're both parentheses. So what I'm kind of seeing is something like this, right? From A to B right here, and they have parentheses. So my graph should look something like this with open circles or with parentheses, that's your choice. And that my set builder, so if I look at this, this is actually going to be equivalent to something like this. So we can now kind of take a look at x such that A is less than x, which is less than b. So my small number is less than x, which is less than b. So you can start putting these notes together and piecing it. So my smallest number is -1, is less than x, which is less than my largest number, which is 4. And again, you may be wondering, why don't I have equal bars here? Well, it's because these are parentheses, which means open circle not included. Now, there's 2 ways you may see this graph drawn. The first way, open circle, so those are my endpoints. Smallest value is -1, largest value is 4. Now the second way you might see it represented, and I'll show you a different color with this one, is instead of using the open circles, we may choose to use parentheses, because remember, those are the same thing. And notice my endpoints are not included because of that. All right, for the next one, 2.5 comma 4, again, it's very similar to letter A. So we're gonna start with braces, x such that, so my smaller number is 2.5, less than equal to x. Now here's the question, why did I put an equal sign there? Well, this is a bracket, which represents that it is a closed circle. That's why I put an equal bar. X, which is less than or equal to 4. And again, why did I put an equal bar? Well, it's a bracket, so they're both going to be equal to. Okay, now graphically, again, equal bar means the circles are closed, and I do have 2 endpoints. My smaller endpoint is on the furthest left, 2.5, and my biggest or my largest one is on the right, which is 4. So there is my graph. And how does this look if I choose to use parentheses brackets? Well, straight up, those are brackets. You can see that. And that's a bracket there. Smaller number is 2.5. Larger number is 4. So I'm just showing you both representations you might see. All right, and then for our last one here, we have -4 to infinity. So we have an infinity. We have an infinite interval here. So I can see it says from -4 to infinity. And that kind of looks like this, from A to infinity. So graphically, I know it starts here, looks like these two graphs, and goes to the right indefinitely. And also, I can see that this is equivalent to this here, x such that x is greater than a. So I'm just going to leave this right above here so I can kind of reference it. So -4 to infinity, braces, x such that, and it says x is greater than a. Well, in this case, my a is the first number, which is going to be -4. All right, now from here, graphically, we start with our smaller number. That's an open circle. And then we have towards infinity. Infinity is going to be an arrow. So this is -4, and I always like to label infinity just so I can kind of reference and see it. Now, if I'm using parentheses and brackets, that's going to be -4 to infinity, parentheses and parentheses, because we don't really know. Honestly, I would think I would just put an arrowhead actually, not a parentheses, because it doesn't actually stop there. It does go on forever. So parentheses represent open circle -4, arrowhead to represent positive infinity. All right, let's take a look at this next part here, absolute value. So you may already know about absolute value. It says the absolute value of a real number A, denoted by the absolute bar A absolute, is the distance from 0 to A on the number line. So it's a different distance that number, whether it's positive or negative, to 0 on a number line. So the distance is always taken to be non-negative, which means it's going to be positive. So the absolute value of -3, well, -3 is 3 units away from 0, which means it's +3. The absolute value of 5, once again, 5 is 5 units away from 0, so that's why it's +5. Okay, so we know that when we take the absolute value, it's supposed to yield some positive answer, okay? So when I look at example A, it says the square root of 3 minus 1. Okay, so what does that mean? Well, I have no clue what the square root of 3 is. So let's go ahead and put this in the calculator and see what we come up with, okay? So second square root of 3 minus 1, and let's see if it gives me an answer here. Okay, so let's make this let's see if I can do this. How do I convert this to a percentage or a decimal? All right, give me a second here. Let me go ahead and pull this back up. Let's try this. Nope. Okay, so let me see if I can give myself a decimal here. All right, so I'm gonna have to use a calculator here. All right, so we have the square root. Where's the square root of 3 minus 1. Okay, so take a look there. The square root of 3 minus 1, so let me write this out so you can kind of see what I'm doing here. So it's asking me to take the absolute value. So I have the, let's see the color here. I have the square root of 3 minus 1, which is approximately 0.73. Now, that number is positive, so that's going to help me out here. And we're going to keep it as the square root of 3 minus 1. So since it came out to be a positive answer already, I know that in order to drop the absolute bars, it's going to be the square root of 3 minus 1 is my answer. Okay? Because if you take a look, that gave me a positive number. So why don't I write it the other way? If I wrote it as 1 minus the square root of 3, that would actually give me a negative number. So like, let me show you. 1 minus, how can I do this part? Oops. Well, I'll have to figure that out. So let's try this again. Let's do the square root of 3. And then we'll make that negative. And then add it to 1. Okay. Well, obviously I'm having a little bit of trouble using this calculator as well, but 1 minus the square root of 3 does give you a negative value, and that's why we cannot write it like that. All right, let's try this next one here. 2 minus pi. Well, we know that pi is like 3.14. So what I'm going to show you is that if I just did, we're going to drop the absolute bars. We're going to do 2 minus 3.14, okay? And when you do that, that's approximately negative 1.14. Now, the problem with that answer is we know that when we take the absolute value, the answer should be positive, not negative, right? So instead of writing it like 2 minus 3.14, we're going to switch it around, okay? So that way doesn't work. But if we switch it around to 3.14 minus 2, then we come up with a positive answer, right? And that's going to be 1.14, and you notice that's positive. So that's actually what we're looking for, because that allows us to get the right answer when we drop the absolute bars, right? So notice this one doesn't have absolute bars, but we know when we work this out mathematically, it's positive. This way did not work out, so we have to make it where it's pi minus 2. So how do I do this? Well, then the rules, you can put a negative in front. So when you take it out of the absolute bars, you can either leave it as 2 minus pi, which we know doesn't work, or we can actually take the negative part. We're going to take negative and then 2 minus pi, right? And then a negative times a 2 is going to be negative 2, and a negative times a negative is positive pi. So then we pretty much come up with pi minus 2, which is our answer, okay? And really quickly, if you want an easy way to think about it, is if you work it out in the calculator like the square root of 3 minus 1 and you get a positive number, drop the absolute bars, square root of 3 minus 1 is your answer. If you take 2 minus pi and you type it into a calculator and you get a negative number, then switch it around. Instead of saying 2 minus pi, do pi minus 2, and that gives me a positive answer, and that's what I'm looking for, okay? Now, letter C is a little bit trickier. We have the absolute value of x divided by x if x is less than 0. So less than 0 is pretty much negative. So this one's a little bit different than the other ones. So what I'm going to do is I'm going to actually substitute and change these to negatives and see if that works. So instead of having x, we write negative x, and that's the absolute value. And then we have x on the bottom, that's also going to be negative x, right? Because they're less than x, which is, or less than 0, which is negative. Well, we know the absolute value of negative x is going to be x, and this remains negative x. And x divided by x, when you simplify, reduces to negative 1. And believe it or not, that's actually going to be the answer for that particular problem. Okay? There's really nothing else you can do to that, because the only one that has the absolute value is actually the x. And this one right here, we made it positive, but then we have the negative x on the bottom, which converted our final answer to negative 1. Okay? All right, so we're down to the last set of notes here, so let's take a look at this. So it says the distance between 2 points on a real number line. So the absolute value is used to find the distance between 2 points on a real number line. If a and b are any real numbers, the distance between a and b is the absolute value of their difference. For example, the distance between 4 and 10 is 6. Using absolute value, we find this distance in one of 2 ways. All right, so pretty much there's 2 ways to do it. It's either going to be, and we're really looking, so they do 10 minus 4. So the absolute value of 10 minus 4 is 6, and the absolute value of 6 is 6. The other way you can do it, instead of doing 10 minus 4, is 4 minus 10. So 4 minus 10, the absolute value, it becomes negative 6. The absolute value of negative 6 is 6. So notice they both come up with the same answer. And it says, notice we obtain the same distance regardless of the order in which we subtract. So that's the distance between 2 points, and you're using the absolute value to determine that. Now, there is a formula, and it's going to be right here. It says if a and b are any 2 points on a real number line, then the distance between a and b is given by this formula. You either do the absolute value of a minus b or the absolute value of b minus a. It will give you the exact same answer. So for example 3, let me go ahead and show this to you. It says find the distance between negative 5 and 3 on the real number line. So the first way I can do it, I'll call this one a and I'll call this one b. So I can do negative 5 minus 3, which is negative 8. But the absolute value of negative 8 is 8. For the second one, I can switch it around. I can do b minus a. 3 minus negative 5. A negative and a negative become positive. So I have 3 plus 5. And 3 plus 5 is 8. And the absolute value of 8 is 8. So you notice this answer is equivalent to that one. So for the example 4, finally, I'm going to show you that you only need to choose one. You don't have to do it both ways. They're going to work out. So again, I like to just do first one A, second one B. So -4, the absolute value of -4 minus 5. That's the formula, A minus B. -4 minus 5 is -9. The absolute value of -9 is 9. All right, and that's going to complete your notes. You can see right there, that is your homework, page 17, numbers 59 through 72, 85 through 94, 101 through 108, 109 through 116, all. I hope you have a good day. Bye-bye.